Well, welcome. Good to see you again. Sort of seeing you. This lesson is about properties, and properties are characteristics, are the descriptors of a particular kind of substance. And we can divide the kinds of properties into different categories. But first, let's mention a couple of different properties. For example, I can talk about the properties of this piece of paper. This piece of paper is white. It's a specific size. This piece of paper is foldable. It can tear. It burns. There's a variety of different properties, ways of describing this piece of paper, and we could do the same thing with the water. We can talk about it having a particular melting point or boiling point. That when it's liquid, it pours easily. It has it's colorless. It has these specific properties about it. When we can divide these properties into a couple different categories, we can talk about physical properties. And physical properties, you can figure out what those are without turning the substance into something else. Like I can find out if this paper is tearable, okay, if it tears easily, without turning it into something else. It was paper, it is paper, still is paper, and I found out that it tears. It doesn't turn it into something else in the process. Okay. Some of these properties are what we call characteristic properties or unique properties. They're always true no matter the amount of the substance that I have. So for example, if we're dealing with the water, everything else around it being the same, always freezes at 0 degrees Celsius, 32 degrees Fahrenheit. It boils at 100 degrees Celsius to 112 degrees Fahrenheit, assuming that the elevation stays at sea level, and a couple other factors stay the same. So these are properties that don't change. I can have a lot of water, very little water. The boiling point doesn't change. Okay, so physical properties, whatever it was before, the substance it was before, it stays that substance even as I'm trying to figure out that particular property. Chemical properties, on the other hand, turn the substance into something new. So, for example, if I take the paper and I want to find out if it's combustible, if it's going to burn, it's paper now. Hey, look, it burns. Paper burns. But it's no longer paper. Now it's ash and carbon dioxide and water. I turned it into a new substance. So this is a chemical property. Chemical properties, in order to figure them out, you have to end up turning the substance into something new. Okay? Which then gets us to this idea of chemical and physical changes. A chemical change is when it turns into something new. It went from being paper to being ash. Physical change, the substance stays the same. So physical changes, it was paper, still is paper. Okay, so as I tear it, okay, now I have, instead of one piece of paper, I have two. I can tear that again. I got smaller pieces of paper. But the physical property, it's a physical change because the substance stays the same. On the other hand, a chemical change involves turning it into something new. So it's paper right now, and as I burn it, it turns into ash, carbon dioxide, and water. Put it in the water here. Okay, so I turned it into something new. It was paper, now that it's ash. Okay, that's a chemical change. If I think about the water, if I freeze this water and turn it into ice, it was water, it turns into solid water, but it's still water. So that's a physical change. I would have to turn it into a new substance. Like I can split the water and turn it into hydrogen gas and oxygen gas, and now it's a chemical change that turned it from water into something new. So physical properties deal with properties of a substance that doesn't turn it into something new to figure them out. A physical change, it stays the same kind of substance. It might change in size or volume or state, but it stays the same kind of substance. And a chemical change, you turn it into something new. You turn it from water or from paper to ash when you burn it. So that's a chemical change. Okay? There's ways of looking for chemical changes. We're going to do a whole lab that deals with that. but you look for things like new odor. You can smell that. You can look for temperature changes. I felt that. You can look for a color change. We see that. Bubble formation under some circumstances that's visible, and something what we call a precipitate. And you'll see that in the lab where a solid forms out of two solutions and settles to the bottom. So these are evidences of a chemical change. I want you to compare and contrast chemical and physical changes. You can set up a double bubble like this. I haven't got my Leonardo da Vinci writing down well enough yet, so it appears backwards, but you can put chemical properties on one side, physical properties on the other. You can use examples and your understanding of them to say, okay, this is what they have in common. These are what they have. This is about chemical changes, and this is about physical changes that they don't share in common. And then I want you to draw a substance undergoing a physical change and then the chemical change. I gave you some examples. You can use my examples, or you can come up with your own. Okay? Make sure you get a signature on the page. So this is page 2 in your notes. Part 3, matter has observable properties. Make sure you get a pair of signatures so I know you watched the video. Fill in all the parts if you want credit. Okay? If you have questions, make sure you ask in class.